Okay, this is our last chance to get to know what we need to know for the test. This is Unit 6, Review B. Again, same stuff, different problems. So we will get this taken care of, and then we would be on to the test itself. So again, we begin with these probabilities right here. The key to success on this is, again, set up your calculator. So X is the list, so these are the actual numbers, and the number of them is the frequency, which we'll put in as list 2. So that's where we're going to start right now. So we set up our calculator. If there's stuff in there, get rid of it. Okay, so we have those, and then our frequencies associated with those numbers. Oh, missed that one. All right, so I'm kind of randomly button pushing here, so I probably want to take a glance to make sure I have everything the way that it's supposed to. I do. Okay, so the first idea is to find a probability of each individual thing. So what are these individual probabilities? And so to get that, what you have to do is you have to take the number of things. Like, so for instance, tens. It'd be 28 out of, and then what you do is you have to know what is the grand number of things. And I think they say that this is, I don't know, I guess they don't say. And so we'll call it like 240 or whatever that is. And that's how you find the individual probability. So it's the individual frequency divided by the sum of frequencies. So it's the individual frequency, it's the individual f divided by the sum of f. So the probability of anything individual is the f divided by the sum of these. Okay, so again, we're going to be getting a probability coming off of this, and I'll store that as list 3 because I'll need it in future calculations. So let me just kind of put this stuff down here temporarily, but I'm going to store this as list 3. Okay, individual probabilities. I have to do the f divided by the sum of f. So I go f, which is list 2, divided by the sum. Oh no. The sum of f. Okay, so those are the individual probabilities in that list. So what I need to do is I need to take that list answer and store it as list 3, like I said I would. So list 3 are the individual probabilities, and that's what the first question is asking. List 3 are the individual probabilities. They want to know what are those individual probabilities. So in this situation, we have x's, which are 10, 11, 12, 13, and what we're going to do is we just constructed a list of these individual probabilities of each one of these individual things. So we're finding the probabilities of those x's. So the 10 is that very first one. Again, take a look at the bottom big decimal, not the highlighted one. Because if I don't want to see somebody say this is 1676. Okay, because that means you're looking at the highlighted number and not the rounded number. The rounded number is that bottom long decimal, which is 1677. You specifically round that one. This next one you don't round. This is 1796. 1317. 0838. 0958. 1078. 1018. And 1317. All right, so now we go to these other problems, and it's just kind of putting these things together. So what's the probability that an x is between 12 and 15, including the 12 and the 15? So that would be 12, 13, 14, and 15. Probability that x is less than 13. Okay, notice how it does not include the 13. All right. The expected value is mu, and that's going to be the sum of x px, which are things that you have stored in your calculator. X is list 1, px is list 3. So this is just going to be the sum of x, which is list 1, px, which is list 3. So that's the sum of x px. Okay, that's my mu, which I'm going to store as the letter u. And then I can go to my standard deviation, which is sigma. And again, now that I stored that mu as the letter u, I have all these things represented. And so again, I'll just, x is list 1. Mu is the letter u. Px is list 3. Okay, here's where we are given likelihoods of things, and we are asked to, in essence, find information about it. So on these problems, what I see is the total number of some things is 32. The individual number of successes, this is where you usually go from 0 to the total number. However, in this problem, we're looking for a very exact number, 28, exactly 28. The probability of that happening is 84%. That means failure is 16%. Again, that adds to the number 1. If I add these things together, that equals 1. So in essence, if you need a Q, what you can do is take 1 minus P if you have a difficult time with that math. And then the formula is the probability of a certain number of successes is NCR, P to the R, Q to the N minus R. So what does that mean in this individual problem right here? That means NCR C R P to the R Q to the N minus R. Okay, down here we're doing the exact same thing, but this time we're asked a flurry of different probabilities. So when I make that R, I am going to list it out from 0 to whatever n is. So here, for instance, I see the total number of things is 9 athletes. That means the number of successes would be 0, 1, 2. Don't forget to start counting from 0 all the way up to the number 9. And what I'm going to do is I'm going to put that in my calculator as list 1. I'm going to make that my list 1. What else do I have here? I have a probability of success. In this case, it's 80%. That would mean failure is 20%. The probabilities in general is I'm using the formula NCR, P to the R, Q to the N minus R. I am going to be storing this as list 3. I'm going to clear out the junk. So list 1 is 0, all the way up to the number 9. And so I plug and chug into my formula. So N, C, R, which is list 1, times P to the R, again that's list 1, times Q to the N minus R. Okay, again, that kicks out a list. Not a big deal. What I'm going to do is I'm going to take that list answer and store it as list 3. Okay, now let's see what the problems are that I have to solve. First one is, what is the probability that all 9? So that's the probability of 9, straight up. At least 6. Probability of at least 6. So that's probably going to be, that is greater than or equal to 6. So that is 6, 7, 8, and 9. That's a big problem, but I think that's probably going to be the easiest way to do it. No more than 4. So here's again where I'm going to get a little bit more clever. So no more than 4. So if all the probabilities are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, let's take a look at stuff that we already done and what we are asked to figure out. So we're asked to figure out what is 0 to 4. Okay, now again, if I add up all these probabilities, it'll be equal to 1, 100%. In the previous problem, what I just did is I added up 5 to 9, or excuse me, 6 to 9. Okay, which is good, but what I'm going to do is I am going to take off this from 1. So what I need to do is I need to put a 5, probability of 5 onto that, and then take that off. Okay, so mathematically, writing it like a mathematician, this is what I'm going to do. I'm going to take 1 minus. So I'm going to put the probability of 5 onto that probability that I just found, which was when the success is greater than or equal to 6. And that'll find the probability of 0, 1, 2, 3, and 4. Okay, get after it. So here the first one is asking what is the probability of straight up 9. That's 1, 3, 4, 2. Here I need probability of 6. And use that bottom decimal, don't use the highlighted decimal. Gosh darn it, hold on. Okay. Again, don't overthink this next one. 23% of the students own calculators. How many out of 140? So that'd be 23% of 140. And last but not least is this problem where we're asked to find mu. Let me change colors here. Same color colors here. And sigma. All right, so really the key to understand here is think of the x as the letter R and do it how we've just been doing problems. So here we see the grand number of high school graduates is 5. R would be 0 to 5. Probability of success is 67. Failure is 33. And the probability of one of these things is NCR, P to the R, Q to the N minus R. All right, so again, things to understand is think of R as the letter X, and that will be, again, list 1. That'll be list 1. And then P of R is the same thing as saying P of X, which again, we are going to be putting into list 3. All right, so we begin with this R into our calculator. All right, I find my probabilities, which I'm going to store into list 3. So the probabilities are N, C, R, P to the R, Q to the N minus R. Okay, individual probabilities. I am going to take those probabilities and store them into list 3. Alrighty, so now I have X, which is list 1. And I have P of X, which is list 3. So just like I did right back here, these problems. Same idea. So here I have the sum of X, Px. I'm going to store that as the letter mu. This is mu, which I'm going to store as the letter u. So again, I have an X, which is list 1, have mu, which I just find, which is the letter u, and I have Px, which is list 3. Another perfect paper.